Okay, in this video we are discussing the first part of Chapter 9, so Chapter 9, Section 9.1. Now Chapter 9, you may have heard me talk about how Chapter 9 deals with matrices, which is the plural of a matrix. So a matrix is something you probably have never seen before, and you still won't see it in this section. We can use matrices to solve systems of equations, and so that's why this section 9.1, it's dealing with solving systems of linear equations, why it's in this chapter, because you can use what we're going to learn about matrices to solve these equations, and we will do that some in section 9.3. The plan is to do 9.1, then jump to 9.7, which really introduces the arithmetic of matrices, how to add matrices, subtract, multiply, that kind of thing. And then we'll come back and do 9.3, and in 9.3 we will learn how to use matrices or aspects of matrices to solve systems of linear equations. Okay, so to start with, let's just talk about linear equations. If you need a refresher on how to solve equations with two variables, now we did a little bit of this already when we talked about solving systems of conic sections and that kind of thing. Here specifically we're talking about linear equations, but there is a review in the book. Go back and look at the part of section 9.1, pages 846 through 851, if you sort of need a refresher on substitution and elimination with two equations with two unknowns. Just to talk about that a little bit, when you had two equations, two linear equations, they either intersected at one spot, the two lines were parallel, so they never intersect, so there was no solution to the system, or the two lines, maybe they didn't look exactly the same because they were in different forms, but the two equations actually generate the same line. So a point on one line is on the other. So every point on one line is a solution to the system because the two equations are actually the same line. All right, so this is kind of a visual, like if we were going to solve them graphically, this is kind of a visual of what's possible. We usually, when we solve them by substitution or elimination, but you can get no solutions. You could get infinitely many, or you could just get one when your system is two equations, two linear equations with two unknown variables. Okay, but what we're going to talk about is three equations and three variables with three equations. So if we think about 2x plus 3y equals 5, that is just a linear equation. But if we introduce another variable, let's say we throw in a minus a z in there, instead of a line, we end up with a plane. So we add a third dimension. So let's talk about this. Normally, we draw XY coordinate system. We're not going to be graphing any of these, but just so you can visualize what's going on. So we have an X and we have a Y. And then coming out of the paper at us is going to be our Z. And so if we want to graph in 3 dimensions, then we would have, say there's a point in space. You can't really tell very well, but my pencil isn't on the paper, but it's up above the paper. So you might go over a certain X value, up a certain Y value, and then come out of the paper a certain Z value. Now, it's hard to represent a 3-dimensional space on a 2-dimensional paper, but often we'll do something like that, and we'll call this a Z, and then we'll make it sort of dashed going back. And so I might go, over 2, up 1, and then come back out here 4 or whatever values. So it's hard to represent that because you go over, you go up, and then you come out of the page some, and that's hard to represent on a 2-dimensional page. But if we talk about 3 dimensions, generally we leave the X and the Y where we're used to having them, and then the Z comes out of the paper. All right, now we're not going to actually be graphing any of this. In more advanced math classes, you will sometimes have 3 dimensions. You'll have a Z, but again, it's hard to graph that because you know, it's like, is this point, where is it? And you know, because we're graphing this three-dimensional system on a two-dimensional page, so it's really hard to do. Anyway, so we won't really be graphing those. However, it's good to sort of visualize what's going on, you know, like we did up here with our two lines. So now we have three equations with three variables, so we have three planes. And so our goal is to find out where the three planes meet. So this is what we're going to, whenever we ask you to solve a system of three equations, three unknowns, there will be one point. Now these are drawn as though they're all the planes are all perpendicular to each other, and that doesn't have to be the case. But there will be one solution in any equation, system of equations that I give you. Assume there's going to be one equation. But just to visualize what else is going on, the three planes might intersect in such a way that there's a common line. Two of the planes might be the same. They might coincide with each other, and then a third one, so a line as well. All three planes might be the same plane. And so that means any point on a plane is a solution to the system. The three planes could all be parallel. None of them intersect, so there would be no solution. No one-point solution. And then so here we have, you know, linear solutions up here, but these, they would have no solution at all. This one, there's no common, you know, two of the planes are parallel and the third one intersects them, but there's not one common point or line that lies in all three planes. Same thing here. No, there's no one point or even a line that lies in all three planes. There's a line here that's in plane 2 and 1, but it's not in plane 3, that one up here. So, or you could have something like two that are coincident and a third one that's parallel. Again, no solution in that case. All right, but we're going to relegate ourselves to systems that actually have one-point solutions. Okay, because they get complicated, so we're not going to do anything else other than that. So I have sort of developed some rules for what you should do. These systems, example 1, these systems can be pretty complicated sometimes, and everybody is going to solve them in a slightly different way. And so when I'm trying to grade your paper, it's going to be beneficial if you kind of follow some general rules that I'm giving you. That way, if you're solving it differently than I am, and you're not showing me how you're going, you know, then I don't know where you made your mistake, and it's almost impossible to find a mistake sometimes, or at least takes a long time. And so since I have to grade a whole class worth of these on the next test, then it would be good if you followed the following procedures. Okay, so the first thing we want to do is we want to number each equation. Also, write pretty small. I didn't give you a whole lot of room on these notes. So I'm going to number each equation. 1, 2, 3. And I'm circling them so that I don't get that confused with a number, or a coefficient, or anything like that. All right, so I've numbered the two equations. Now what I want to do is I want to take two of the equations and manipulate them algebraically, one or the other of the two equations, and make one of the coefficients the same but opposite. And that's going to allow me to eliminate that one variable. All right, so I'm going to look at, I'm going to use 2 and 3. So I'm going to tell you that by saying I'm using 2, and I'm rewriting it. 2x plus y minus z equals 2, and I'm going to use 3. So I see that the z is the same but opposite, so I'm going to add 2 and 3 together. X plus y plus z equals 2. So I'm going to add these up, and this gives me 3x plus 2y equals 4. And I'm going to call this new equation, equation 4. So I'm going to use 2. There's no right way, wrong way to do this. You have to pick 2 of the equations. Make sure that the 2 coefficients of one of the variables are the same but opposite. So when I add them, I get 0z. And now I have one equation with just 2 variables. Okay, now I want to do that same thing again. I can't use 2 and 3. I got to use either 1 and 2 or 1 and 3. 2 different lines, 2 different equations, not the same 2 that I used to generate 4. And I want to eliminate the same variable. all right? It's not going to help me if I have two equation 4 and what we're going to call 5, and those two equations have two different sets of variables in them. So if this one has x and y, I can't have another equation that has x and z. I got to have that other equation, it's got to have x and y as well, because then I have two equations with two unknowns, and then I can use my elimination substitution that I learned in Algebra 1. Okay, so I think I'm going to use equations. I'm going to use equation 1. I'm going to look and say, well, I already eliminated z, so I got to eliminate z again in the next equation. So I see that equation 2 has a negative z, and equation 1 has a positive z. So I'm going to choose those two, but I got to make this a negative 6, right? So that way, when I add 1 and 2 together, the z's are going to cancel. So I'm going to use 1 exactly as it is. So I'm going to write out, I'm showing you what I'm doing because I said, oh, I'm using 1. 3x plus 9y plus 6z equals 3. All right, and then I'm going to say, oh, I'm going to use 2, but I'm going to multiply it by 6. So you can see I'm saying I'm taking equation 2 and I'm multiplying it by 6. And then that's going here. All right, so that's going to be 12x plus 6y minus 6z equals 12. Okay? And now I simply add because my z's are the same. So when I add, I get 15x plus 15y equals 15. And essentially this is equation 5. Except now I can see, oh, yeah, I can do something with this, right? I want to simplify this equation if I can. This is nice. I'm simply going to divide everything by 15. So x plus y equals 1. And I'm going to call that equation 5. All right, so now equation 4 and equation 5 are two linear equations with two variables, two unknowns, and I can solve these by elimination or substitution, whatever you want to do. So I'm going to go ahead and stick with elimination since we're kind of been doing that. I'm going to eliminate. So I'm going to use 4 and 5, and let's get rid of the y. All right, so I'm going to use 4 as it is. Let me do it down here. 4 as it is. So that's 3x plus 2y equals 4. And then I'm going to take equation 5, and I'm going to multiply it by negative 2. Okay, so that's going to be, I'm going to have, let's see here, I'm going to have negative 2x minus 2y equals negative 2. Be careful, it's often we forget sometimes to multiply the thing over on the side, the constant over on the side by this, or to change the sign of it. That's a common mistake. All right, so now I'm going to add these two up. And that gives me just x is equal to, right, 3x minus 2x is x. X is equal to, and the y's go away, x equals 2. Okay, so I have one of my solutions. We are looking for three variables here, right? So we have one of our variable values, x. X is equal to 2. Okay, now I got to go back and take that and substitute it into an equation that will give me another variable. Now I can't plug it into equation 1, 2, or 3 because then I would still have a y and a z unknown. So I have to plug it into equations 4 or 5, and that will give me my y value. So pick the simplest one, I guess 5. So in 5, I'm going to plug in x. So x of 2, I always kind of use parentheses to show that I did a substitution. So 2 plus y equals 1. So now I can see that y is going to be equal to negative 1. All right, so I now have my second equation, second variable value. I have x and I have y. And now I'm going to substitute those in both of them into one of the first equations, maybe 3, because that's the simplest one. I can do it in any one of them I want, but I think I'll just use 3. Okay, so equation 3 now, and again, I'm telling you which equation I'm putting it in by doing this. I'm not just starting to write, because if you do it wrong, then I have to figure out, wait, what equation did they even plug it into? And so it takes forever to grade this unless you give me a roadmap. Okay, so 3, x, that's a 2, plus a y, which is -1, plus a z, and that's equal to 2. So when we take the 2 to the other side and the 1 to the other side, I think you'll see z equals 1. Okay, so like we had in 2 variable equations when we're solving those, we had an ordered pair. We had an x and a y, and sometimes we would write down it as an ordered pair. We can do the same thing here, but this is an ordered triple. So if we're plotting a point like we were doing over here in 3 dimensions, it's not an x and a y anymore. It's an x and a y and a z. To find this location, we want to go over x so much, up some y, and out of the paper some z. So we call it an ordered triple. And so we could give our answer in that format. We could say, oh, our answer is 2, comma, -1, comma, 1. And that's what we call an ordered triple. So if you're told to give your answer as an ordered triple, then you just put it in x, y, and z sort of in that order. Okay. So again, let's just kind of review what you're told to sort of do up here. So we number the 3 equations. We use 2 of the equations. We look at the coefficients and we say which ones would be nice and easy to eliminate. And I see that the z's are already opposite sign and the same coefficient, right? Same coefficient but opposite sign. That's perfect. So I used equation 2 and 3. I didn't do anything to them, and I just put them down. I added them, and I got my equation 4. Then I got to eliminate those same variable. I got to eliminate z somehow. So I decided 6, that's positive, negative z, let's use 1 and 2. So I used equation 1 exactly as it is. You can see I didn't multiply it by anything. And equation 2, I'm multiplying by 6. And so I took and multiplied each of these terms by 6, added that up, and that would be equation 15, equation 5. But before, I went ahead and simplified that because, I saw that, oh, that's pretty easy to simplify. That's the same as x plus y is equal to 1. And so that's a much simpler equation to use. And so I did that first and called that equation 5. So now equation 4 and 5 are what I'm going to solve for. And I want to now eliminate. You could do a substitution. Like, I could have taken this x and moved the y to the other side, or moved the x to the other side, y equals 1 minus x, and did a substitution. Could do that as well. Doesn't matter. But one way or another, I got to solve these 2 equations to get another variable. In this case, it was x equals 2. That has to get placed in either equation 5 or equation 4 to find the other variable, in this case, y. And then once I have x and y, I go back and I plug it into one of the original equations, and that will give me my last variable, z. Okay? All right, let's go on to the second page. Okay. So this first one, it's kind of complicated, but it's really just trying to get you to come up with some equations sort of on your own. So it says here that find the equation of a parabola. We've done a similar thing in the past, but one of the points they gave us in the past was a vertex, and we're not given that any of these are vertices. So none of these is a vertex in this parabola. So what we want to do is we have we don't have the parabola in the HK form. We have it more in the standard form. Y equals ax squared plus bx plus c. And we have 3 points that it goes through. So what we can do, and again, you need to write really small here because I didn't give you a whole lot of room. What we want to do here is temporarily plug in an x and a y value into this equation, and that will generate one of our equations for us. So let's do that. Let's plug in the first one. So that's going to be a 4 is equal to a times x squared, which will be 4, plus b times x, and x is 2. plus c. So we have an equation. We have an equation that has got a's, b's, and c's in it. Okay. Let's rewrite that though. Let's 4a plus 2b plus c equals 4, and we're going to call that equation 1. Okay. Now, when we plug in the x and y here into this equation, I'm going to go ahead and leave the y on the right side this time. And then -1, when I plug that in for x, that's going to be just 1a, so we'll just call that a. And then when I put -1 in for the x here, that's going to give me -b. And then when I plug, then it's just c. There's no constant. It's just a constant. There's no variable next to the c. Okay, so that's equation 2. I plugged the second point's x and y values into the general equation and got the second equation. And let's do that same thing. Let's leave a 5 out here. We know it's going to be a plus c. When we plug the -2 in for the x, for the b, that's going to be -2b. And then when we plug the -2 in, that's going to be 4a. And that's equation 3. All right, so we got to look through these and say, okay, which equations would be easy to eliminate? Now, you might say, oh, 2b and -2b, that's nice. But you just got to remember that you have to use that same equation again. I think I will use, I think I used 1 and 3. Indeed, I'm getting rid of my b's when I did this. So I think that's what I'll do. I'll do equation 1. I'm not doing anything to it. 4a plus 2b plus c equals 4. And equation 3. That's 4a minus 2b plus c equals 5. And now I'm going to add those. Now you could subtract them and then you would want the coefficients to be the same, but I find that sometimes when you're subtracting positive and negative numbers, people goof up, and so it's always safest to just make the signs opposite, the same but opposite, and then add. And then you're less accident prone. So we have 8a, the b's are going to cancel, plus 2c equals 9, and I have my one equation with two variables, so that's equation 4. All right, now I got to do that again. I got to get rid of b, go back to 1, 2, and 3, my original equations here, and I'm going to eliminate the same variable b. So I don't know, let's do maybe 1 and 2, right? They have opposite signs. 2 and 3 are fine, but they already have opposite signs. I'm going to have to multiply through by a negative to make one of those positive, but 1 and 2 are a little bit nicer. So 1, I think I'm going to leave as it is. So that's 4a plus 2b plus c equals 4. And then what could I do to 2 to make it the same? I need to multiply that by 2. So I'm going to take equation 2, and I'm going to multiply it by 2. And so that gives me 2a minus 2b plus 2c equals 2. And now I'm going to add those. All right, that gives me what? 6a, the b's cancel, plus 3c equals 6. All right, now notice again that I have a common factor among all three of those terms, and so maybe instead of that one, it's always easier generally to have simpler coefficients. So let's go ahead and divide through by the common factor. So that's a 3. So I'm going to have 2a plus c equals 2, and that's equation 5 now. All right, so now I have two equations. You can see it's easier to figure out how I'm going to eliminate one of my variables here than it was with the other earlier form of equation 5. So we'll go with this one. Looks like maybe the C would be the easiest to cancel. And so let's make the C's. You could cancel the A's too, but let's cancel the C's. So I think I'll take equation 5, and I'm going to multiply it by -2 times -2. And so what does that give me? Negative 4a minus 2c equals -4. Remember to multiply the 2 by the thing as well. And then equation 4, I think I'll leave it alone. That is 8a plus 2c equals 9. And I add those. I get 4a, the c's go away. 4a equals 5. And so a equals 5/4. Okay, so that is my A. And now I need to go back and find my B, my C and B. So clearly the C is the next one I'm going to get because I'm plugging it back into equation 4 or 5. And probably it looks like equation 5 would just be simpler. So let's... Now, actually, now that I think about it, 8 would help cancel this fraction out. So I'm going to plug it into 4. Again, it doesn't really matter. But 8, plugging in my A, is 5/4 plus 2c equals 9. So my 4 and my 8 cancel. That gives me a 10. Plus 2c equals 9. And I take my 10 to the other side. That's going to give me -1. C equals -1/2. All right, so I have 2 of my variables. Now, sometimes your answers will be fractions. Don't be alarmed if you have a fraction. It's possible that you could have a fraction. If you get some nasty fraction like 27/13, probably that's, something's wrong, right? So you can have fractions, but we're not giving you horrible answers. So you might, think about like, oh, wait a minute, this is a fraction, that's fine, but it is a really nasty fraction. Go back and check your work because there's a good chance you might have done something wrong. All right, now we have to take this and plug it back into one of the equations. 2 is the simplest one, but I'm looking here at equation 1. The 4 will help me cancel the fraction. That's kind of nice. So I think I'm going to use equation 1 here. And again, I'm telling you where I'm plugging it into equation 1. So 4 times 5/4 plus 2 times -1/2. Oh, wait a minute. That's B. 2B. Plus C. Okay, well that didn't really eliminate it, but oh well. Equals 4. All right. So this will be 5. We can take that to the other side, and the -1/2 would take that to the other side. This goes over. It's -1. The 5 gives us -1. And then we add a half, so I think 2b will be equal to -1/2. All right, and then we divide by 2, so b is equal to -1/4. All right, so we have our 3 solutions. 5/4, -1/4, and -1/2 are a, b, and a c. So they asked us to find the equation, so let's just put those things in. We have y is equal to 5/4 x squared minus 1/4 x, and then minus 1/2. So that is the equation. They were actually asking us to find the equation, not just the coefficients, a, b, and c. So once you find them, in this case, you'd plug them back into that equation to get your answer. Okay. All right. Let's look at number 3. Similar problem to the last one, except now we're dealing with a circle. So we have 3 points on a circle. So we have the general form of the equation of a circle. Again, write kind of small if you can here. didn't leave you a ton of room for this. So if we take, let's figure out what these points are. So we have 1, comma 3. We have, negative 4, comma 2. And we have negative 1, comma negative 5. All right, so plugging those in, let's see, x squared. Let's just start with, I guess, this one. So x squared is going to be 16 plus y squared, which would be 4. Again, we're doing this point here. Plus ax, so that's going to be minus 4a. I'm going to go ahead and put the x value in front of the a because it's the coefficient of the a. Plus y, so plus yb, so that's 2b. Plus c equals 0. All right, so let's go ahead and put this kind of in the form that we're we're used to, the a, the b, the c, and the constant on the other side. So we'll call this negative 4a plus 2b plus c equals, and the 16 and the 4 will take the other side, negative 20. And let's call that equation 1. All right, and so I guess let's do, this point next. All right, so let's write what we have when we start with, when we plug the things in. So x is 1, so that's going to be 1 plus 3, which is the y, squared is 9. And then a, so that'll be plus 1a plus the y, which is 3b, plus c equals 0. And again, let's put it in the same form we did up above. A plus 3b plus c equals negative 10. And then the last one down here, we'll call that equation 2. So let's plug the rest of those in. So x squared, that's going to be 1 plus 25, which is the y squared, plus a times x, so that's going to be negative, negative a. The y is negative, so negative 5b plus c equals 0. So let's rearrange that. That's negative a minus 5b plus c equals negative 26. And we'll call that equation 3. All right, so we have to look at this equation, and this equation, and come up with a variable that's going to be easy to eliminate. I see that the c's are all the same, right? C, and C, so probably that would be the easiest one to eliminate. So let's use equation 1 and equation 3. No rhyme or reason why use one or the other, but let's just use 1 and 3. So I'm going to use 1. That one I'm going to leave alone. So we have negative 4a plus 2b plus c equals negative 20. Really, there's almost no, no one better set of equations to use than others. Everyone's going to use slightly different. That's why it's really important that you're labeling what equation you're using to generate your equation 4 and 5. So equation 3, I'm going to multiply that by negative 1. And that's going to be my c's the same. So that gives me a plus 5b minus c equals 26. And let's add those. That gives me negative 3a. What was my b here? I think that was supposed to be 5b, isn't it? Yeah. I didn't really write that very clearly. It looked like BB, 5b. When I add that up, I get plus 7b. My c's go away, and this is equal to positive 6. So that's equation 4. All right, so we got to do that again. Let's use, I'm just going to use 1 and 2 this time, I think. So equation 1, let's multiply equation 1 by negative 1. All right, so equation 1 by negative 1, that is 4a minus 2b minus c equals 20. And then I'm going to use equation 2 just as it is. All right, equation 2. So that is a plus 3b plus c, so you can see the c's are the same but opposite, equals negative 10. Let's add those up. So that's going to be 5a plus b, 1b. The c is going away, and that's equal to 10. So that's my equation 5. Sorry, I should have written a little bit smaller. Barely fits it in there. All right, so that's my equation 5. So now looking at equation 4 and 5, these two equations here, I have to figure out which one I'm going to eliminate. All right, so probably b is easier, right? Because I can multiply this by negative 7 and get my b's. Here I would have to multiply this by 5 and this by 3, the whole equation. So probably just easier to multiply equation 5 by b. But again, there's more than one way to do this. And again, so important for what, why you should be telling me what equations you're doing, what equations you're using, and what you're doing to them. All right, so I'm going to just leave 4 alone. Rewrite it over here. Negative 3a plus 7b equals 6. And I'm going to take equation 5 and multiply it by negative 7. Okay. So negative 7 gives me negative 35. What else? Gives me negative 7b. And gives me negative 70. Okay. All right, so when I add these up, I get negative 38a. The b's go away, of course. This is equal to negative 64. Okay. Of course, I basically just lied in the last problem, said, oh, the fractions are generally going to be nice. These fractions are a little nasty, but so a is going to be equal to 64 over 38. That reduces a little bit. We can cut both those in half. 32 over 19. Okay, so that's kind of ugly, and I would be suspicious of that. I would want to go back and check my work, but of course, this one's fine. But I think we would, assume it on a quiz or a test, we would give you slightly nicer, like the fractions up above, but I don't think I would give you anything like 32 over 19, because that just seems like a mistake. Okay, so we have A. So we have our one answer, A. Now we need to go back and find our B. So I'm going to plug that in to one of my two equations. I guess neither one is really a nice one to plug it into. I guess I'm going to use equation 5. But notice I'm telling you that. I'm saying, all right, I'm going into 5. So 5 times 32/19 plus B equals 10. All right. All right, so if we move this stuff to the other side, we end up with B and get a common denominator of 19. We get B is equal to, that 10 becomes 190 minus 160 over 19, so 30/19. Okay, that's our B. And then finally, we want to plug that into one of our equations. I don't know which one's the best one. Yeah, I'm just going to pick 2. Let's see, I'm trying to figure out where I'm going to space this so that it's best. Let's try to do it right here. All right, number 2. Let's plug it in there. So we have A, which is 32/19. I substitute that in, plus my B, which is 3 times 30/19, plus C equals -10. All right. I move all that to the other side. I end up with C equals, what is that going to be? Get common denominator there. That's -190/19. And then minus 32/19. And then minus 90/19 if I move them all over. And then simplifying that gives me -312/19. Okay, so, kind of nasty fractions. Again, don't expect that you'd get such nasty ones on the test. All right, so now we need to write the equations. I'm going to do that up here. So we get the equation up here. We have x squared plus y squared plus, what's our a? Our a is 32/19, so 32/19 x plus our y, by. So we put our b, that's 30/19 y, and then plus our c, so I guess I'll just say that's -312/19 equals 0. All right, so again, didn't leave you a lot of space to do that one, but that's our answer in that case. All right, last example. So on this last example, again, we'll try to write as small as possible here. Let's do this so we don't interfere with our other equation, other solution. All right, so you notice these equations, they are not linear equations. You'll have your x and your y in the bottom. This would not, open up Desmos, see what this looks like, but it's not a line. So what we want to do is sort of turn this into a line. And we can do that by doing a little substitution. So what if we let a equal 1/x and b equal 1/y? So what equations would we have then? We would have 2 times a plus, we would have a b equals 11. So that would be equation 1. And then this one would be what? 3a plus, minus 5b is equal to 10, and that would be like our equation 2. So we've turned our two equations into two equations that are linear. Like we have substituted in a variable, and now we can solve a and b like we're used to. It makes it much simpler. All right, now we don't have to do we don't really need to number these equations. I mean, it might be helpful, but we don't really have to because it's not 3 equations; it's just 2. Okay, so we'll use this is essentially you're going to use your method like you did in Algebra 1. So let's see. I'm going to do a elimination, and so I'm going to take equation 1, and I'm going to multiply it by 5. That way my b's have coefficients that are the same. So that gives me, 10a plus 5b equals 55. And then equation 2, I'm not going to do anything to. So that's 3a minus 5b equals 10. And that gives me, 13a equals 65. All right, and so then we divide by 13. A is equal to 5. All right, now we're going to take that and plug it into one of the other equations. I don't know. Let's plug it into equation 1. So equation 1, we have 2 times 5 plus b equals 11. So I think we can see b is equal to 1. All right, so then if a is equal to 5, so that means 5 equals 1 over x. I think you can see x will be equal to 1/5. And y, 1 is equal to 1 over y. Well, that one's easy. Y equals 1. All right, so we have these two, x and y's, and we essentially solved the system. You could do this one, since it's just x and y, you could do it as an ordered pair. Where do these things intersect? And that would be 1/5, comma, 1. But the original things are not linear equations, but we are just going to do a temporary substitution using this substitution in order to turn them into linear equations. We can solve them and then unsubstitute back out again. Okay? All right, so this is your homework at the bottom of the page. Due next class.